Assalamu alaikum everyone. This is lecture 21 for CS116 Object Oriented Programming. So let's get started. In last lecture, we were discussing exceptions. We saw what exceptions are, uh, and we also learned that there is a variety of built-in exceptions available in Python, and we can use these built-in exceptions to provide default exception handlers. And if we want to handle these exceptions by ourselves, we can provide user-defined exception handlers as well. And there are constructs available in Python that helps us build these user-defined exception handlers. And these include the main block, the try except block, and then we also saw this optional else and finally blocks. And we also learned that a user can raise an exception by himself also in the code if he wants to. In today's session, we'll see a simple but a very comprehensive example to demonstrate the use of all those constructs that we studied in last lecture, like how we can use try except block, how we can raise our own exceptions, and how we can use those else and finally blocks. So we'll use the same example and we'll see variations of this example to make use of all those constructs. And in the end, I'll show you how we can define our own exceptions. Now, let's see the problem statement first. In this program, we'll define two functions. One will be called input in range and second will be called create list. Now, this first function input in range, it will take two values, a minimum value and a maximum value, and it will be used to take input from the user. So what it will do, it will first prompt the user to enter a value, an integer value, and then this function will check that value against these limits, min value and max value, and it will see if the value entered by the user lies within that limit. If that is the case, it will simply return the value to the caller, and if the user enters something that is out of range, then it will prompt the user again to enter another value. In fact, it will keep on prompting the user until the user enters a valid value. Or by valid value here, I mean a value that lies within that specific range of minimum value and maximum value, right? So this is what this function does. But one problem that can happen here is that user can enter in valid value, out of range value, and that is absolutely fine because we are handling that. But a user can also enter something which is non-integer, like some string or some name or something else which cannot be converted into integer. So in that case, an exception will be raised. So in all the versions, we'll be handling this single exception. Okay, so we'll come back to this in a while. Let's see the second function first. The second function is create list function. It is taking three arguments, n, minimum value and maximum value. Now what this function will do, it will create a list of n elements, right? So n will be passed to this function as parameter. So it will create a list having n elements, and each element of that list, it should lie within the range of minimum and maximum value. That means that this function will call that first function, input and range function, for each value of the list. So let's suppose if n is equals to 3, that means we have to insert 3 values in the list, and for each value, each time this input and range function will be called, and it will ask user to enter a value. That value will be checked against the range, and then input and range value will return the valid value to this calling function create list. That will be placed in the list, and then we'll repeat this procedure for the second input and the third input. Okay, so that means we are calls will be nested here. So first we'll call create list function from the main program, passing these three values, and then this create list function will in turn call input and range function n times to create that list which it has to form, and in the end it will return that list to the caller. Let's start coding that practice problem. Now you guys fasten your seatbelts because I'm going to show about 7 versions of the same code to you. So this is the first version. Here what we'll do, we'll just write the simple code and we'll see if user enters something other than integers, then exception value error will be raised, and we are letting Python handle that error. Okay, so in this version we'll mainly concentrate on understanding the logic of the program, right? This is the first function that we are coding, input in range. Now, if you recall what we discussed, that this function will be passed these two values, minimum and maximum value. This function will ask the user to enter a value, and that value will be checked against this range. If the value lies within the range, then it will be returned to the user, and if it's not in range value, then the user will be prompted again and again until he or she enters a valid value. So this is the message that I'll be printing, right? And you see I'm using that formatting here because I want to print that custom minimum and maximum value passed as parameters in my message. So I'm using that F for formatting this print statement. Now, since I'll need to prompt user again and again, so I need a loop here. So I'm using an infinite loop here, and here I'll take input from user. The message has already been printed using that print statement, and after that I'll check this value to see if lies within this range, right? So if it lies within this range, I don't have to do anything else. I'll break from loop. In fact, since this is a function, I can simply return from this function. So I'll return from this function, which will obviously break the loop. And if this does not happen, if this condition is not true, or if the value entered by user is not within the range, so I'll print another message and then I'll loop back. Okay, by looping back, what will happen? It will again prompt the user to enter a value. That value will again be checked against this range and will be returned if okay. Otherwise, this loop will keep on running. Now the second function, create list, it takes three arguments, n, minimum value and maximum value, and what it will do, it will create an empty list and it will put n elements in that list, or it will append n elements to that list, and for each element it will check if actually for each element it will take input from the user and will check it against this range. So this function will be using that first function, input in range. Let's see how. First of all, I'm initializing an empty list, right? Now I have to take input n values. So that means I can run a loop having n values. So here it is, right? And inside this loop, I have to take in a value input from user and have to check it against this range. So that can be done by that function input in range. So I'm calling this function, right? So this function will return me a valid integer value that lies within this range, minimum and maximum value. And if that happens, that value will be appended to my list, right? So when the loop is over, my list is ready. I'll simply return this list to the caller. So I hope there is nothing difficult in these two functions. Now let's analyze this code for errors. Actually, we'll focus on just one error, the error that will be caused by the user input, because user is inputting those integers value that we'll be placing in that list. So we are just focusing on that point. So there, the user can make two types of mistakes. Either he or she can enter a value which is out of range, or he or she can enter a value which is not an integer value at all. So for the first case, like if the user enters something out of range, that is not a problem here because we have already taken care of that in the code. So we'll be repeatedly asking the user for a new value unless he or she enters a valid value. And by valid value here, we mean that a value which is within range. So that is fine. But for the second case, if the user enters a non-integer value, our code will not work. Actually, it will work. It will raise an exception. And because user was expected to enter something, some integer, but he or she is not entering that integer. So a value error will be raised. So this is the point where that exception will be raised, right? So if a user enters an out of range value, that is absolutely fine. That could be converted to integer. It will not cause any exception. And after that, we'll check that for the range and we'll solve the problem. But if the user enters something which is not an integer, then this conversion to integer will raise an exception, and that exception will be of value error type, and we have to handle it. So either we can handle it directly, or we can leave it to Python. So in this first version, we'll see how Python handles it, and what the message that Python prints at the output, what does that mean. In order to raise that exception, let's call that function from main module. So here I am calling this function create list. I am passing 2 as first argument. That means I need 2 elements in my list, and those 2 elements must lie within this range 10 to 20, both values inclusive. So this function will create that list, and it will return that list to me, which I'm linking to this variable lst, and then I'm simply printing this lst value. So this is the flow. First, this main module will be executed. It will call this function create list. Create list will create another namespace for this function create list, and within this create list we'll be calling this third function, right? So this is the flow of our program. Now let's run this code. I'll discuss 2 cases. The first one is when no exception is generated, and then we'll see what happens if an exception is generated. Now in first case, again we have 2 cases. So the first one is when the user enters perfectly fine values. So what will happen, the create list function will actually we need to enter 2 values. So the create list function will call the input in range function for the first value. So let's suppose I enter 17. This is perfectly fine. This 17 will be returned to create list, and it will place this 17 in that empty list. And then it will call again the same function for second input. And let's suppose second time I enter 20, which is again fine, because our range was from 10 to 20, with 20 being inclusive. So this is also fine. So that means the list now will contain 2 values, 17, 20. That list will be returned to the main program, and main program is printing that list, which is this. So this is perfectly fine. This is the first case. Now let's see if the user enters something which is out of range. This is the first value. This is perfectly fine. It lies between 10 and 20. Okay, second time, let's suppose I enter 4. So what my code will do, actually right now I am inside that function input in range. So my code will print this message, value out of range, please try again, and I again enter something wrong, and then it prompts me again, and this time I enter a correct value. So now this 15 will be returned to the caller, 13 and 15 will be placed in the list. That list will be returned to the main function, which will print this. So here it is, right? Now let's see what happens if an exception is raised. So when will the exception be raised? It will be raised if I enter some non-integer value. So let's suppose I enter this 11. Now this 11 is a string, it's not an integer. So when Python will try to convert it or typecast it to integer, this will raise value error, right? And value error is actually an exception. So since I'm not handling it in my code, Python will handle it for me. And what Python will do, it will simply terminate my code, and it will print an error message on a screen. So if you run this, you will get this error message. And you see it's a very, very detailed error message. Let's try to understand this. Now, this is a traceback. Actually, it will print the whole trace from the point where exception occurred up to the point from where it all started. So first, let's see it in forward way. The first 2 lines, they are from main module. So they are indicating that this create list function was called from main module, okay, on line 17. And then the next 2 lines, they are saying that when create list was called, there in create list method on line 14, what happened? Some error happened or something wrong happened. And that happened when that input in range method was called. So the last 2 lines were are indicating that this input in range method function was called, and within this function here is the point where the exception occurred, right? Now, how Python was able to print this traceback? Actually, it tracked backwards from the point where exception occurred. So exception occurred within this function input in range. So what Python did, Python searched for handler for this exception within that function. But we have not handled that exception in that function. So that means Python will not be able to find any handler for this error within that function input in range. So what happened? Then it went to the caller function. Create list is the caller function for input in range. So it went back to the previous level, and there in create list, again Python searched for an appropriate handler, but it was not able to find it there because we have not provided any handler there even. So it went to the previous module, which is the main module. So basically the point is Python tracks backwards from the point where exception occurs towards the main module, right? So if it finds an exception handler at any of these places along the path, along its traceback path, then it executes the except block from there, right? That means if the user provides any handler, then that will be executed by Python. But if Python is not able to find handler along this path, then Python will handle that exception by itself, which is the case here. Since we did not handle that exception by ourselves, this is just a simple code without any exception handling code. So what will happen? Python will not be able to find any exception handler, and then it will handle it by itself. So when it handles it by itself, what it does, it simply terminates your program and it prints that message. So this is what happens. So that means that if we want to handle this exception, we have to place a handler along this traceback path. So here I want you to observe that there are three places where you can place your handler. You can either place your handler in input in range function, or you can place your handler in create list function, or you can even place your handler in main module. So in the next versions of this program, I'll show you, I'll place handler in each of these three places and we'll see what difference does it make. Now the second version that I'm implementing here, in this I'll handle that exception by myself. Like I'll place the handler in my code, and as we discussed that there are 3 points where I can place exception handler. So in this version 2, I'm placing that exception handler in the main module, like farthest from the place where exception occurred. So this is my first case. So the whole code or the code pertaining to those two functions, it remains same, right? This remains same, and this one also remains same. I'm trying to put this try except block in the main module. So this was my code. I just wrote these two statements. So I'm putting these statements in a try block, and then I'm associating an except block with it, and I'm specifying the name of the error, value error, because I'm sure that this kind of error will occur because we are working on this error only right now. So here what I want to do, I just want to print a message. So now Python will not terminate my program. It will execute this except code, and whatever I am doing here, that will be done. So let's run this code. What I have to do today is an exception. I have to enter something non-integer when the program prompts me. So here it is. Let's suppose I enter this 11. 11 is not an integer. So here exception will be raised. Python will search for handler in input in range function. It's not there. It will come to create list function. Handler is not there. Then it will come to main module, and there it will find that except code because I'm handling the exception here. So now what Python will do, it will terminate the try block like it will not go to the next statement, which is the print statement, but it will come out of the try block and except block will be executed. In except block, what I'm doing, I'm simply printing this error message. So this will be printed on screen. So after this, my main module doesn't contain any more code, so my program will terminate. Now let's see a second version. Here what I'll do, I'll place my exception handler in the middle layer. That means the create list function. So input and range code still remains the same, right? And here's the code for create list. I'll put most of the code in the try block. So I'm initializing an empty list, and then I'm using this try block for these two main statements. And then I write a except block where I'm simply printing an error message, and then I'm returning this result. Now here you see this return statement, it's up to you. You could have placed it inside the try block also, and here I'm placing it outside the try block. So there will be a a small change in the output, but if exception doesn't occur, then both codes will work the same. So here what will happen, this return result statement will be executed in any case, whether an exception is generated or exception is not generated. So if exception is not generated, then this result will contain valid values which will be returned to the user. But if exception occurs, then it depends where exception occurred. For example, I was supposed to input two values and exception occurs on second value. That means first value has been successfully placed in this list. So that will be returned. And if it happens on first value, then an empty list will be returned. So let's test this. Okay, before that, the main module code, it remains same. I have removed that try except block from here because I'm placing the handler at only one place right now. Now let's see what happens when this code runs. Okay, if I want to cause that exception, what I have to do, I have to enter some non-integer input. Here it is. So when I enter this 11, an exception will be raised at this point. So Python will first search for exception handler in input in range function where it's not there. So it will come to the caller function create list, and here it will find that exception handler. So what it will do, it will simply terminate the remaining try code, and it will come to the except block, and there this error message will be printed. Okay. After this error message is printed, we come out of except block, and you see what happens there. It returns the result. Now, since exception occurred when we were entering the first value, that means we have not placed any value in our result list yet. So result list is still empty. So that empty list will be returned to the main caller. Okay, and there we are printing that list. So here it is. So here you can see clearly that our program was not abruptly terminated, but we handled the exception and we returned some output from that create list function, and our program proceeded normally towards the end. So it's up to us how we handle that exception. Now let's see the third case, which is actually the version 4 here. Now I'll place that exception handler in the innermost function, which is input in range. So input in range is the function where actually that exception is occurring. So let's see what happens if we place it here. So here I'll change this code. I'll put most of the code, the relevant code, within the try block. So here's my try block. So I'm putting this loop inside it. So it's the same loop. I'll input value from the user. I'll check it against this range, and if the value is true, it will be returned to the caller. Otherwise, I'll print this message and will take another alternate value from user. And I'll keep on doing this until user enters some valid value, right? So that was it. This is my try block. And in except block, I'm placing some error message, right? Remaining code, that means the code for create list and the main modules code, it remains same, right? So let's run this and see what difference does it make. Again, we'll follow the same procedure to raise that exception. I'll enter something non-integer, right? Okay, now before that, you notice one thing here. um, I'm calling create list method, create list function from main module, and the first argument is 2. That means when I come to the create list function, it will call input in range function 2 times, because it has to input 2 values and it has to place those 2 values in the list, right? So let's suppose I enter an invalid value the first time, right? So what will happen? An exception will be raised at this point. Python will look for this, for its handler in this input in range function, which is there. So it will terminate that try block. That means that range checking if construct will not be executed, and we'll directly come to the except block. And in except block, what's happening? It's simply printing this output, and here it is. Now after printing this, what will happen? The program will not terminate. It will simply exit from this function input in range gracefully. So it will go back to the caller function create list. Now the question here is what value has been returned, because the return value is being appended to that list, which is called result. So since we are not returning any value in this function, we all know that a none is returned. So that means the first element that will be placed in my list result will be a none, right? Now after coming back here, the loop is not over, because this was the first iteration. I has to go through 2 iterations because n is 2. So again this method input in range will be called, and this time let's suppose the user enters a totally valid value, right? So that means that range checking will be done. That is also fine. 12 is within the range, so it will be returned to the caller function. So when it will be returned, that means the second value which is being placed in that result list is 12. Now the list contains 2 elements. The first one is none and the second one is this 12, and this list will be returned to the caller, where it will be printed, and here is it. Here is that list, right? So out of the 3 options that we discussed, like where to place this exception handler, I hope you are able to see that it's better to place the handler closest to the point where exception actually occurred. So because there you have more control and you have more information about the error, so you can handle it in a better way. Now let me emphasize this point by version 5. Let's see what we have there. Now here what I want to do, I want to ask user for a corrected input if he or she enters a non-integer value. Like I want to if user enters something out of range, we are asking the user again and again until he or she enters a valid value. We want to do the same thing with this non-integer error also. So since this is the place, the innermost function is the place where exception occurred, so we can do that using that try except block. So here is the code. Now what difference I am making here is that I am taking this loop out of the try except block, right? So this was my infinite loop and the remaining code is in the try block, right? It will check for the range, and if it's okay, it will return from here, and otherwise it will print this message, right? Now in except block, what I'll do, I'll simply print some messages. And since this try and except block has been placed within that infinite while, so after except block executes, I will not go back to the calling function. Where I'll go back to this while loop. So what it will do, it will again ask the user for the value. So I printed an appropriate message in the except block, and after that I am asking the user again for the input. So that means now my program will not even terminate or will not put that none invalid value in my list, but it will ask the user again for a valid value, and it will not terminate until the user enters a completely valid value, a non-integer value as well as a value which lies within the range. Okay, I'm not running this code for you. You can run this from the file and you can see the output for various cases. So this is the concluding point for all the versions that we have seen up till now, that if you are placing an exception handler, you should place it closest to the point where exception occurs, because at that point you have more information, you can handle that, you can even provide some remedial code for that, as we just saw that we can even correct that error if we handle it at the right point, because there we have more information, and that would be the best place where you can handle an exception. Now let's see another version. um, you see, there were two types of error that can be caused by user's input. Either user could enter something which is totally non-integer value, or a user could enter an integer but that integer is out of range, right? So that means there are two types of error. For one, Python was raising exception and we were handling that exception, and the other one was not a value error by default. So we were providing our own code to handle it. Now what here I'll do, here I'll use the same except block to handle both these errors. So what I can do, I can use the raise statement or the raise keyword, and I can raise the exception for out of range case also. Like if user enters something non-integer, Python automatically raises an exception. But if the user enters something out of range, I'll raise that exception by myself in the code. So let's see that, because in this case what we can do, we can handle both the exceptions with the same except block. So here's the code. This first statement remains same. This is the while loop which we placed outside the try except block, and here starts the try block. This is the first statement in which we are taking input from the user. Then I'm checking this value against this range. If the range is fine, then we simply return that value to the caller. Otherwise, I'll raise this exception. We saw this format in last lecture, raise, and I'm using the name of the exception which I want to raise, value error. These round brackets are optional. If you remove them, then also this will work fine. So here now I am raising an exception by myself. So if the user enters non-negative value, non-integer value, then an exception will be raised by Python. And if the user enters a value which is out of this range, then this statement, raise statement, will raise an exception. And then the except block that I'm putting here, it will handle both of them. Right? So I'm printing a general message, an invalid entry. Invalid entry means it could be out of range value or it could be a non-integer value. And okay, we place that while loop outside so that we can repeatedly ask user for the value. So in both the cases, it will ask user for the value until or unless the user enters a completely valid value. The rest of the code remains same. So you see here we are using that raise statement. Now in this last version, I'll show you how we can make use of these else and finally constructs. So I'm using the same code, but I'm making a small change. I hope you can recall that in the main module, what I was doing, I was printing the list on screen in the end. So instead of printing that list on screen, I'll be printing that list in a file. So let's see how we can incorporate this else and finally block with this logic. Now here what I'll do, I'll put this file writing code into an exception handler, right? So the previous code remains same. You can use any version that I have shown you for those two functions, create list and input in range. I'm changing the code of the main module. So I'm placing that code in a try block. In try block, what I'm doing, I'm first printing this message, then I'm opening a file, and then I'm inputting a list from user, right? So now create list method function will be called, and if this function does not create any exception, it will return a valid list which will be assigned to this variable lst, right? So what I want to do, I want to check this code for errors. So if any error or exception occurs within this code, I simply print this error message. And if exception doesn't occur, like there is no error and the list has been created properly and perfectly and has been assigned to a list variable, so in that case what I want to do, I want to write this list into the file. So if the code runs perfectly, I want to write the file, so I place this in else block, because we know that we place those statements in else block which we want to execute if no exception occurs, right? And okay, I'm printing a message too. And finally what I want to do, I simply want to close the file in the end. So here it is. Now see, this statement of finally, it will be executed in any case, and you can see this is optional. If you do not place this finally block, then also this f dot close statement will be executed in any case. So let's run this code. Okay, it's a simple code. Let's run it for two cases. First one, when no exception occurs. Okay, this statement will produce some output. It will print this statement on screen. Here it is, right? Now it will open a file now, and then it will create this list by calling this function. Now this function, what it will do, it will prompt the user for a value. Let's suppose user enters two perfectly fine values, 11 and 11, and these will be placed in a list, and this list will be returned and assigned to LST, right? Now what happens next? Since no exception occurred, so this except block will be skipped, and since no exception occurred, that means that else block will be executed. So in else block, what I do, I simply write this list in a file and then print this message, and this will be printed on screen, right? And after that finally block will be executed and it prints this additional message, right? Now let's create a scenario when some exception occurs in this code. Okay, this first statement will be printed on screen. Here it is. Then I open this file, and now I want to call this function create list. Now you see a change here, that highlighted one in red. Now instead of passing an integer, I am passing a string. So what it will do, it will create problem in this create list method, because in this create list function, I'm using this value as a loop counter, and that has to be integer. And I have not handled that exception over there, so that means an exception will be raised when this string will be used in that in range function, and it will come back to this point. So that means code will come here, and that exception has to be handled by this try block. So what it will do, it will terminate here and it will come to the except block, and this message will be printed. Okay, now since we terminated the try block due to exception, that means this else block will not be executed. So we are not writing that error prone list to the file, and we are not printing this message. Instead, we are coming to the finally block and we are closing the file. Here it is. Now, the last thing that we'll see in this lecture or in this topic of exception is how to create an exception. Now, this is really, really simple, because as I told you that exceptions are classes, and you can you simply have to write a class. And the things which you need to take care is that you have to drive your class from exception class or base exception class, and you have to provide an appropriate name, and then you can pass any number of arguments to the constructor of your class. Now let me show you a simple example for this. Okay, in this first example, I'm creating a simple exception class and I name it invalid withdrawal, and I'm driving it from this base class exception, and I'm doing nothing inside it. Okay, so this is an exception which I want to handle in my code, but I don't want to do anything specific in it. So I can just do this. I can just write that pass statement there. Now, if I want to raise this exception, I'll have to raise it explicitly by using that raise keyword, because this is not a built-in exception. So I'll have to raise it explicitly. So this is my main code where I want to raise this exception. I'll simply use this keyword wherever I want, and I can call the name of this exception with or without using those round brackets. And then I can write a catch block or the except block. Here I'm simply printing this message. So that's how you can write a simple exception class. in this second example, let's develop some code within that exception. Now, I'll go through this code quickly because we are running out of time. If you do not get it, we can discuss it in the live session. Otherwise, I think it's a fairly simple code. There is nothing difficult in it. So here's my same class, but this time I'm defining an initiator function here, and this initiator function takes two arguments, balance and amount. So what I intend to do, I intend to keep these two values, balance and amount, as instance variable within this class, and I'll use this to print messages and to implement an instance method also. So here I'm calling this supers init method. That means init method of exception class will be called. It will simply display this message, and the special thing about this message is that I'm printing that amount which has been passed to the initiator function. You can see that towards the end, the right hand side. Then I'm simply creating two instance variables and I'm assigning these amounts, these values to them. Okay, this is another instance method, and it simply returns difference of these two instance variables. Now let's include some code that actually raise this exception. Let's suppose the user enters a value for balance and a value for amount, and it happens that balance is less than amount. So we have to raise an exception. So this is what we can do. Let's suppose these two values 25 and 50 have already been entered by the user. Now 25 is the balance and 50 is the amount which user wants to withdraw, which is not possible. So I am raising this exception, and it will call the initiator. Okay, now after I call the initiator, I want to use those inner methods also, that overage method and these values also. So what I can do, I can catch this exception using that as keyword in E. So now E contains or points to the object of that invalid withdrawal type for my case. So E dot balance has now been initialized to 25, and E dot amount has been initialized to 50. So what I can do, I can print that overage amount using this statement. This is pretty much explanatory. So you see here we saw how we can define a simple exception, how we can even pass arguments to that exception, and can use them in a try except block. So that's all for today's lecture. In fact, for the week, this is what we did today. We saw this really comprehensive example in which we explored the process of exception generation and handling in quite detail. And then we saw how we can define our own exceptions. It's a fairly simple process. We just have to derive our class from either of these two classes, and the remaining rules are the same. Thank you.